Well, excellent. So it's 3 o'clock here in Sweden. Welcome everyone who's dialed in to join us for this webinar, which is going to be centered around applying NLP techniques in the finance sector. I'm Thomas Carlson, and I'm the enablement manager here at Peltarion. And today I'm being joined by two guest presenters and who are going to share some good and interesting information on this topic with us. First of all, we have Jakobs, who's the head of AI solutions at Silo AI. And Silo AI is the biggest private AI lab in the Nordics that build AI as a service for a number of customers and across a number of different countries and also industries, including financial institutions, central banks, media and retail. And we'll hear more about what Silo do and Jakob's background in just a short while when we hand over the presentation to him. But Jakob himself has a background in both academia and industry, so I think he's going to share some really good perspectives with us today. Our second presenter is one of my colleagues here at Peltarion, Mikael Hus, who's a data scientist in the Peltarion team, and similarly brings extensive experience with him of having worked on machine learning projects and AI related projects in both industry and academia. So Jaakko and Mikael are going to take us through the presentation today. And the way we've structured this section, or this session, is in three different sections. So Jaakko will kick us off by setting the scene a bit, explaining how we apply natural language processing or NLP and how how to think about these techniques, to then do a deep dive into three specific use cases, which we'll hear more about. So some real life examples there. After that, Mikael will round off the presentation by talking about some state-of-the-art techniques that we're seeing in this area, as well as relating it back to some of the work that we're doing here at Peltarion. It's a bit of a sneak peek on some of our projects and plans. As you may have noticed already, we have muted the phone lines while we do the presentations, but we have also planned some time at the end for questions. So what we'll do is that we'll pull together the questions at the end of the session once we've heard from Jaakko and Mikael, and I'm sure they're going to be more than happy to do their best to answer any questions you might have. And if you do have a question, then there is a function in this tool that we're using, GoToWebinar, where you can use the Q&A function to type in your question, and then we'll, as I said, review those at the end of the call. We're also recording this session, just so you're aware of that, and we will be sending out the recording after we've held this session. But with that said, it's time for us to get to the interesting part. So I'm going to hand over the scene to Jaakko, who's going to explain, first of all, who Silo are, and then take us through these three use cases. So I'm just going to hand over the control to you, Jaakko, and then
Hello everyone, my name is Jakobs. As said, I work at Silo AI as the head of AI solutions at UK, and also as a tech lead for natural language processing, or NLP as we so often call it. My original background and also PhD are in theoretical physics, but for the past years I've been working with data science and machine learning, first through my own company and then at Silo AI. Silo AI is the largest private artificial intelligence lab in the Nordics. We create AI as a service with clients served on 4 different continents, and our clients include central banks, financial institutions, heavy industry, airlines, maritime, media and retail. So quite a large palette actually. Our mission is to help create a world with safe, human-centric artificial intelligence. NLP is short for natural language processing, which is a field in artificial intelligence. And as the name implies, it deals with natural languages as opposed to computer languages like, for example, Python, Java, C, or C++. Natural language could be text, speech, or even sign language, any form of natural communication. There is a lot of text in the world, and currently, because of that, the brunt of applied NLP efforts focuses on making better use of all this text. While speech is starting to catch up, the text still has a lot of headway, and there's still a lot of things to do. So that's for the N and L. Next comes the P for processing. There are many kinds of processing that we can do nowadays. Most of it is about processing language as an input. The input goes into the machine, which then works its magic, that is crunching numbers. As such, computers cannot understand languages, and they won't be able to do so in the foreseeable future. So what that means is that we need to think of some clever ways to transform the problem into a numerical one. There is a great number of tasks that we can do here. I'm not going to go through an exhaustive list or even all the different categories, as that alone could fill a webinar of its own, just to name a few. Syntax-related tasks deal basically with the structure of the language input, such as lemmatization and stemming of words. Lemmatization removes the inflection in the words and resulting in the basic form, and stemming basically cuts the sort of core of the word out. These are not so often directly used in applications, these tasks, but they can be rather important steps in pre-processing the language data, or they can be used to create additional features for machine learning. And we are going to visit some of these as an example in my first real-world use case. Most of the interest lies on the semantic side. For example, these include machine translation, question answering, or named entity recognition, which is about spotting names of people, countries, and companies, and so on. On the other side, there is another interesting area of NLP that has been getting more and more interest lately. This area is the natural language generation, or NLG. It is about generating language, as the name implies, as the output of the machine. Usually it's text or speech. This, of course, is nothing new. It has been around for decades, like most of the other things. But until recently, any effort for machine-generated voice, it sounded basically like Stephen Hawking, and I don't mean this in the sense of a world-renowned genius. All around, there has been a lot of progress in NLP and AI in general. Actually, last year was a real bonanza for us NLP scientists, as there were several revolutionary methods coming out in the research papers and also being applied already. These include, for example, Elmo and BERT, of which we will probably be hearing more about later in the webinar from Mikael. NLP is nothing new. It has been there for more than 50 years, actually, as is the case of artificial intelligence in general. Of course, for the first decades, the triumphs of NLP left something to be desired. While the first results were promising, and it was actually said that yes, we are going to solve whole machine translation problem in, say, 5 to 10 years, but in a way it turned out to be like nuclear fusion, so it's still to be solved. First, the NLP approaches were mostly rule-based, then statistics-based, and now mostly machine learning and deep learning based. In a way, one could argue, with a lot of opposing views, of course, that it is these advances in the last 5 to 10 years that really matter in modern applied NLP. A colleague of mine commented recently that you can see the difference in the attendance of NLP conferences, or sort of a shift. There used to be a lot more linguists attending those events, and now it's mostly people with background in deep learning. And this part, the later part, is what I'm going to be talking about. NLP with machine learning and mostly with deep learning. As said, this is only a part of the whole, and also if you look at the slide, you may notice that much of the bots actually fall outside of artificial intelligence, and the reason is that a lot of that is currently happening still with, say, simple rules, which doesn't, of course, mean that they don't work. Even with all the successes of machine learning and NLP, it's important to keep in mind that these technologies and all models are maybe not that valuable per se. The value comes out of their usage by utilizing AI in the right places with a clear, measurable, impactful business goal. Now, as for finance, it's all about numbers and has been so for ages. Therefore, there are sophisticated ways to deal with that numerical data, with statistics, etc., even before machine learning era. But textual data has been rather underutilized for a long time, as it in most cases required manual labor, which meant that it has been slow and expensive. With the development of modern advanced AI methods, alternative data has become much more viable in finance. This alternative data might include things like company filings, social media, news. One could say that what is considered alternative data in finance today will be just mainstream data in a few years. And actually, what I just mentioned, these might actually be borderline cases in the sense that many might consider them mainstream data already. Currently, there's a lot of interest in so-called exhaust data. Now I'm going to give you 3 examples of projects that we have worked with over the years at Silo AI. Of course, there are so many other things that you could do, and also things that we have done as well. But I feel that these are rather clear-cut cases with giving an descriptive examples. The first use case I'm going to talk about is a bond prospectus analyzer. Our client was, and actually still is, an investment bank, and their people had to go through the several hundred pages long prospectus documents, and they basically had to do it in hours. Now, that's a rather difficult task to do, and the main interest in those documents and all those pages was that they were interested in finding the risks related to a company in question, while most of the hundreds of pages were not really that interesting. And actually, the company issuing the bond has an incentive to obfuscate the risks involved. So in a sense, it's not very easy to spot it. That was our task. We set out to use AI and especially NLP to increase the efficiency and accuracy of the process of going through these bond prospectus documents and analyzing the risks. As the investors care about the combined risk of the portfolio, these have a large impact on the investment decision. Better information enables better decisions, and finally, better bottom line. The AI task can actually be broken down into 2 separate tasks in this case. First, finding the risks related to the company, and second, classifying those risks. Our understanding of the granularity of the risks changed actually during the project. This is quite often the case when people with different backgrounds, say ours from machine learning and the content experience from our clients, there's discussion which creates a better understanding of the problem. In the end, the categories we ended up with were global, industry-specific, and company-specific or idiosyncratic risks. Before we can just chuck all that text into a neural network, we need to do some preparations though. And actually, the first question of any kind of machine learning project should be its data, to show me the data. And yes, there's always something problematic about it. It might be just, say, missing values, broken encodings, and so on and so on. And if nothing else, there's no documentation, or it's very cryptic and possibly in Mongolian. In this case, we had the very unlucky situation of having almost no data at all. In most cases, that is fatal to the project, but in this case, we were lucky and also worked hard to find a data set that was a close enough match to train a useful model. Here's an example sentence and what are the steps that we took in the project to pre-process it before feeding it into a neural network. So the sentence is, Acme operates in cyclical industry and its financial performance is sensitive to adverse changes in the European and global economic conditions. Now, first we lemmatise it. That is, we remove the inflections, get the basic form of the words, and we also tokenize it. That is, basically we chop the sentence into words, and this might also include punctuation. We also removed stop words. This is not always done, but in this case we did. And the stop words are words that are in a way too common to be carrying relevant signal. It might be removing articles like a, the, and is. And then actually the opposite, we removed words that were too rare to be well learned from the data. This is again a reminder of the limits of most AI solutions. If there is no or very little data, the machine will not learn about it. If it says, say, only once a certain word, it might just as well be Chinese. And last, we made all sentences equally long by adding padding tokens to the beginning of the sentence. So basically a word with no meaning. As mentioned before, computers are good for crunching numbers. So the question is, how do we translate, and now I'm using the term loosely, the language into a format that the machine can work with? And especially we can then apply neural networks on. Now, embeddings are a technique for doing that. And more specifically, in this project, we used word2vec, which, as the name implies, takes in words and outputs vectors. Now, one could say that this is a relatively new method as it came out in 2013, but it is also starting to become obsolete with the advances during last year. This is just to illustrate the timelines in the field. But getting back to the method itself, one of the nice features of embedding into a vector space is that you can then find words or sentences with a similar meaning pointing in the same direction. And then you can do also vector algebra, which is what you see on the slide. If you don't remember from school what that means, then let's take a closer look. So this is reduced to 2 dimensions. In real life, these word vectors have a lot more dimensions. In this project, we had 300 dimensional vectors. But what you find is that you can take the words king, then minus man, plus woman, and find that it equals queen. This is one of the big reasons why word2vec became so popular so quickly. But truth be told, the results are not always this good. But still, word2vec is a nice technique since it's rather easy to use and it usually brings okay to good results for many tasks. Also, closely after this paper with the results of king minus man and so on, there came another result. Someone noticed that, okay, what happens if I try doctor minus man plus woman, and what do you get? A nurse. Okay, that's bad. Now this brings up the question of fairness and biases. That's not the topic for today, but it's worth noting that it took only weeks before someone came up with a solution to this problem of fairness. So it's not actually a fundamental problem of the AI method itself. It's an engineering task to just solve it. And in a way, the problem lies in the data that's made by us humans. And the other side is, how would you know if something like this was happening inside the head of a recruiter? You can't know it. But with the case of AI, you can actually explain what the model is predicting or what decisions it's suggesting, and you should be making that explanation. So actually AI can help bring transparency if done correctly. But okay, we are now ready to insert the processed text into the neural network. In a way, it has become a matrix. For this case, we tried several methods, but what we found to work the best was a rather shallow neural network with two convolutional layers followed by pooling layers, and then dense layers in the end to classify the risk. Now, convolutional neural networks are perhaps best known for dealing with visual data, images. But we have used them, I could say, rather successfully also with text and other problem types and input types. One of the important characteristics of convolutional neural networks is that they are a bit less prone to overfitting. Overfitting is a regular problem in machine learning where the model sort of concentrates too much on the detail of the data, and in a way you could say that it can't see the forest for the trees. What you get out of the neural network is its prediction on what type of a risk does the input text refer to. Now, this is all very nice, but if you want someone to use this, the results have to be brought to the users. Since the current work process was working with Adobe Reader, and we didn't want to change too much, we created a simple document reader with added functionality of presenting the machine-found risks and their relevant classification. The user can then check whether their classification is correct or not, and the machine will learn from all these techniques and improve. This service was deployed on Google Cloud with the web-based document reader. Now, the next case I'm going to talk about is also for an investment bank. They were interested in signals that they were currently not utilizing in a robust manner, and especially in CEO earnings calls. These quarterly calls include the management section and the Q&A section about the state of the company. And they are available from actually several financial data providers. We set out to investigate what kind of a signal we could dig out of the sentiment of the call, predicting longer-term returns of the company. The first part is basically the same as for the last case. That is the data pre-processing with cleaning, embeddings, and so on. So let's jump over that part and into what we did on the modeling side. To try out sort of a baseline, we first did a quick and dirty lexicon-based model for this. Basically, you associate a sentiment score to a word, so you have a word and a number in the lexicon. This is a visualization of our dictionary words embedded with WordSwag. As discussed earlier, these vectors are 300-dimensional. Since that is a bit difficult to visualize, we sort of flattened it into 2D with a method called t-SNE. And then we did some clustering. The result is, and what you see, is that words with similar meaning are close by. For example, words relate to energy or medicine. The sentiment score is shown with the color, with blue being negative and red being positive. Okay, one of the first things that we found was that the baseline model was against oil and nuclear industries by default. Everything that was talking about this ended up negative with negative sentiment. On the other hand, engineering-related terms were positive, and so was science. And most medical terms turned out to be negative. And for a change, something that might be usable was that terms like credit default and so on had negative sentiment. But still, the lesson in this one was that while lexicon-based models are often quick and dirty, they in many cases are too dirty to be of much use. But there's of course different use cases where the result might be a bit different. So we had set out to do something a bit more elaborate. We tried several models with neural networks like CNNs, that is the convolutional neural networks, long-term memory, LSTMs, bi-LSTMs, and so on. But actually rather simple convolutional neural networks seem to be working the best. Now, what you see on this slide is the network visualization from Keras. If you know what that means, great. It might give you some ideas on what you might try. But if you don't know what it means, don't worry about it. The main thing is that in the model and the network, we had several parts. One for the management discussion section, the Q&A section, seasonal inputs, and the industry sector inputs. And this combination worked best. And in a way, this is kind of natural because, as you might expect, the management discussion is rehearsed and cleaned in a way. So the signal is maybe not so strong, while in the questions and answers section, it's more, in a way, uncleaned because you can't prepare for what the questions will be. And while I said that we tried LSTMs in this case, they didn't work that well. And personally, I'm not a huge fan of those. As with many other methods, they seem to work way better in a random archive paper than in your own project. So we tried several prediction targets, as there is not really a ground truth for the sentiments available. At this stage, we were not yet trying to make the best growth predictions, but just to understand if the model really performs and can perform. Also, because of this, we wanted to make the model explainable, so that we can show the user what the model is looking at in the text when it's making a given prediction. Say that in this part of the sentence or this sentence is what's giving positive vibes, so to say. At that time, there wasn't a very good library for this available, so we worked on some of our own methods for that. But nowadays, there's better libraries available out of the box. Again, many of the first steps in the project are, the last case is about predicting unemployment from the sentiment in the news. Now, news data is nice in the sense that it is usually rather easy to come by. But the question then is, what do you want to look for in it? I mean, there are so many different NLP use cases related to news, ranging from controversies related to CEOs or political unrest. But here we are interested in unemployment. We started with the overall market sentiment in the news, but actually, as often happens in exploratory projects, the focus shifted slightly into more, in this case, more specific events that have an impact on unemployment. Again, many of the first steps in the project are the same as in the last two, except that in this case, one of the first tasks was creating a text data annotation environment, as there wasn't a labeled dataset available. So with this annotation environment, users could label data on the unemployment news, or news in general, about which were relating to unemployment. And before that, we had done some rather simple filtering, but we also tried to use query expansion on that, which is also an NLP method. As this is a more recent project, instead of Word2Vec, Elmo is our tool of choice for the text embeddings in this case, and they work with entire sentences instead of just words. And after this step, we can then use, again, neural networks for getting a score for the unemployment sentiment in the article, whether it's corresponding to unemployment rate going up or going down. And of course, one news article is hardly an accurate descriptor of anything. The result of a single article or the results of those are then aggregated to get the overall picture over time. And with better understanding of unemployment in the future and getting a more detailed view in that enables, of course, better and more efficient methods to mitigate any problems that it causes, which is the interest of our clients. That's that for the moment. I'll give now words to Mikael, and if you have any questions, feel free to post them and we can cover those in the Q&A section.
Excellent. Well, thank you very much, Jaakko, for that presentation. As you said, we'll hand straight over to Mikael to continue the conversation.
Thank you. So I will briefly talk about some trends in NLP, some state-of-the-art techniques, and go a little bit into transfer learning and transformers. As Jaakko already alluded to, last year, 2018, is perceived by many to be a bit of a watershed year in NLP, and it's mostly because of some innovative things in transfer learning. And the transformer architecture is something that Google introduced in 2017 already, but it started to become implemented in several state-of-the-art methods last year and this year. And it is built conceptually different from the CNNs and recurrent neural networks like LSTMs that Jaakko talked about. We don't have time in this short webinar to go into that, but basically it is based on something called self-attention, which allows for a better way to train in parallel, and it has also shown to be quite good at keeping long-range dependency information in sentences, for instance. So I mentioned transfer learning, and in general, if we sort of hand wave a little bit, it's about reusing previously learned information so that you can take models that you have trained for one purpose and repurpose it for another task. And for image classification in particular, it has been a standard technique already since 2014 or something like that, to take off-the-shelf models that someone else has pre-trained on a large image data set, usually ImageNet, and repurpose it for your own target domain, your own images. So with a very small modification to the off-the-shelf model, you can get a model for your own data that can work very well, even if you have quite a small number of images. So in NLP, transfer learning is not exactly new, because these word embeddings that Jakob talked about, like word2vec and other types of word embeddings, can be considered a type of transfer learning, but they have some limitations. So in these word embeddings, a word is always represented in the same way. So it always has the same numerical vector and no context awareness. And the predictive model that you build, you sort of have to cobble together by hand, apart from the word embedding that you use in the beginning to get the text into the network. So you could compare it to, in the case of image classification, that you are using some pre-trained edge detectors that can detect some very primitive features of images, but after that you have to construct the rest and train the model. But the newer transfer learning models that have started to come out are getting a much richer representation of the input text, and your model sort of contains more contextual information and can be more easily repurposed for another task with a small modification. So there is no need to reinvent the wheel. You can reuse the model for multiple different problems, as it is with ImageNet and image classification. We already heard a little bit about Elmo. This is one of the impressive breakthroughs from last year, and it's a way to build context-dependent word embeddings. So the same word will get different embeddings depending on where it is in a sentence, for instance, or in general, depending on the context. And with very little task-specific fine-tuning, you can achieve state-of-the-art results on many tasks. It's just a small modification at the very end of the model that you need to do. On the Sesame Street theme, Google also released a model last year called BERT, which proved to be very powerful. And this is using the transformer architecture that I mentioned. So it's not using LSTM or CNN, but it's using self-attention. And it can be used to train on very large text corpora in a parallel manner. Now it's still expensive to train the models in terms of computational resources and cost, but as with these ImageNet trained models, once you have the model trained, you can apply it to other problems, and you don't have to do the pre-training all over again. So it only needs to be pre-trained once, and it's relatively inexpensive to fine-tune and to do inference on. This model broke, I think, 11 records on NLP benchmarks when it came out, and it's still on the leaderboard, as you can see here, places 1, 2, 3 for a question answering task called Squad. And there are pre-trained models that have been made available by Google for English and Chinese and a multilingual model as well. So this is an interesting model because it allows you to take again an off-the-shelf model and fine-tune it a little bit on your own task. And the way it works in brief is that you train it on a very large mass of text, sort of running text from books or Wikipedia, which makes the model learn patterns in language, sort of understand how sentences are built up. And once you have the pre-trained model, you can introduce your labeled training data and do supervised learning or discriminative learning, if you will, Like in this example, for instance, the task is to classify emails as spam or not spam. In some cases, an extra step is introduced as well. So if we think about an application for legal documents, like contracts or something like that, where you want to build a term tagger or something that can check how similar two contracts are or classify the risk or something like that, you might want to start with a model, a pre-trained model for English, let's say, and that one you would typically just download. Don't need to train that yourself. And sometimes you will also want to do further pre-training on top of that model on the target domain. So for instance, legal terminology in English, training on legal documents to get a domain-specific language model. And then on top of that, you take your target texts, the label text that you have, on which you fine-tune this model to do whatever you want to do, sentiment analysis or named entity recognition or similarity ranking or something like that. And in terms of the Peltarion platform, we are building in language-based capability on the platform continuously. The first functionality will appear during summer, and we are looking to support a variety of language processing cases, like text classification, text summarization, similarity search, and other things as well. And we are, of course, keeping an eye on the latest developments and the state of the art. So for instance, we are doing some projects together with clients, cases that are underpinned by BERT. And we are planning to build in BERT support in the platform during the autumn.
Well, excellent. Thank you very much, Mika, as well, and Jakob for taking us through these two presentations. That we're hoping that this has given you a good taste for NLP and how it can be applied with some really good use case examples there from Jakob. This means that we do have time for questions, and I know that two colleagues here are more than happy to help answer any questions you might have. As I mentioned in the beginning of the call, there's a Q&A function or a questions function in the chat bar. So if you wouldn't mind typing in your questions there, and we'll take it from there and kind of go through them. And I'm happy to say that we're already getting questions, so this is a good thing. And the first one was about which models the Peltarion platform would support. And I think, Mika, you actually mentioned that that's primarily BERT, right? That where we're starting in terms of that support. And then we have some questions for you, Jakob. So it's about the timeline for the different projects that you described, so the three use cases. Do you have like a high-level overview of how long those projects took from start to finish, so to speak, the different phases of them?
Yeah, that's a very good question, and of course it depends also on many things. But how we see it at Silo AI is that you should be getting some tangible results on is it feasible or not, and so on, in say 2 to 3 months, sometimes even a bit less. But truth be told, I've also been in projects where it's taken like 6 months first to get the data, and then there's like 2 weeks time to do the modeling. So a lot of it depends on where and how is the data stored. Is it clean, to what extent? I have yet to see in totally clean data, but in some cases it takes months to work with it, and sometimes it's days. So I would say actually that's say 80% of the time might be going to working with data, of getting it into the right format, and then the rest is about modeling. Of course, it depends also on the sort of evaluation criteria that say if you need to do something that happens in like 10 seconds, or if you need to do it in 4 milliseconds, it takes more time to do it, the optimized version. But I think you can expect and should expect to see some results in a couple of months.
Excellent. Well, that's good news, I think, for people listening. That it's actually manageable. Shifting gears slightly, another question maybe for you, Mikael. It's about the Peltarion platform that you obviously briefly talked about. If I build a model using the platform, how can I deploy it to production? You outline the high-level steps there to take.
Yes, so when you have trained a model and evaluated and you are happy with it, you can deploy it to an API. So you will get an endpoint and a token from where you can fetch predictions. So you can call this API in different ways, from Python, command line, and other ways as well.
Excellent. Thank you. If we then go back, so there's some further questions about the different models that I think both of you outlined. So in terms of BERT and Elmo, and the listener asking there is, so is anyone else than Google building and releasing these state-of-the-art models? Is there another player out there in the field that we should be keeping our eyes out for, basically, and then kind of leverage? I'll see, basically, any of the two of you who want to feel encouraged, maybe Mikael, since you talked about, if you start, and then Jakob, maybe you can jump in after that.
Yeah, I mean, there are many players. Facebook has some interesting products like Laser, which is a type of multi-language sentence encoding model that they trained for 93 different languages. Zalando has some very interesting NLP functionality as well, including their own embeddings. Allen NLP made Elmo. Those are a few. Maybe Jaakko has others.
Yes, indeed there are many. I mean, to some extent, the big ones are issuing and sort of competing against each other on who has the coolest stuff. One thing to keep in mind when looking at what's available in a way openly is to really check the license. Is that a couple of times you notice that, hey, this is really cool, we can use it, but no, actually we can't use it because the license is a bit prohibitive. Then there's of course OpenAI, and there was a lot of talk, I think it was last year, on the GPT-2 model, which was like OpenAI was talking about they are revealing everything openly, but that wasn't released because they saw the possibility of misusing it actually. But there's stuff coming out from them as well. And then Mika also mentioned Allen NLP, but there's also other like university collaborations and universities that push out rather useful stuff. For example, you can get word vectors and also train Elmo models for quite a few different languages, 60 or something like that, so on NLPL or one of the sort of university collaboration sites. So indeed, there are many out there.
Excellent, and I think that actually last note there maybe ties into another question we got here about non-English language support. So if we're looking to implement models for non-English text, for example, is that where you would go, or how would you address that type of scenario?
Yes, that's a very good question, and a lot about it depends again on the use case and the available data. If for us clients would have a lot of internal data, say text, so then we can probably train something on that. like straight away from scratch, or use, as Mikael was telling about, taking one pre-trained model and then transfer learning on top of that. So it depends quite a lot. But the fact is that if we look at, say, Swedish or Finnish or French or so on, there's usually some models available, but to be frank, with English it's easier in the sense that you get more out of the box, and the bigger the language is, then usually the easier it is to find something.
Perfect. So I'm currently not displaying any further questions, but we'll give everyone listening just a second chance. So if you do have further questions, as you can hear, we're getting some really good answers. Feel free to type them in. While we wait for another question, I might add that there's one of the listeners who asked whether we would share the recording afterwards, and we will. So there will be an email sent out with the recording. And there's actually a very short survey in there as well. So if you wouldn't mind taking less than a minute to answer a few questions about what you thought about the content, and as a small thanks for your support there, we have some rather nice looking Peltarion t-shirts, which we'll randomly send out to a few of those answers as a small thanks. So, but the recording is being sent out. While I plug that, then there was a further question around the language actually coming in. So you mentioned Chinese, and I don't know whether you are aware of this, but further specifying it, whether it's Cantonese or Mandarin, that would be supported. Whether any of you have any insight into that?
So existing models or pre-trained models for Chinese, was that the question? Yes, there are pre-trained models, and of course, like actually just a few hours ago, I was asked by someone that does it take to have experts who can speak all the languages to work with the models? And in a way, no, but you should have some people to check the results, of course. But say with BERT, I think there's also one sort of
I can comment on BERT. There is a model for Chinese, and I would say it doesn't really matter for written text if it's Mandarin or Cantonese, because the written Chinese is essentially the same thing in both. It's not completely true, but it's the written language is the same and the spoken variants are different.
Excellent. That's really good insights. So at this stage, I'm not seeing any further questions. I think maybe what we'll do is slowly round off. I think to summarize the call, so the intention of this webinar was to give you a taste for NLP, how it's being applied specifically in finance, and some really good examples, as I said, from Jakob. Silo AI and Peltarion are working together on projects, and obviously we're hoping that this presentation has sparked your appetite for testing this out and maybe finding out some more. And one of the services that we're offering together is something that we're calling a Jumpstart package, or a Jumpstart service, which is basically a 6-week consulting engagement where we look at building a proof of concept to see how basically could be any sort of deep learning or a machine learning project, but in this context, how we could apply these techniques to your business scenario and working together on that. So if you're interested in learning more, there's some further information on our website, and I know that we will be more than happy from both companies to sit down and talk about specific use cases that you may have in this. I would also say that if you want to test the Peltarion platform, there's also on the same website a link to actually use our community version, which is available free of charge and with the full functionality of the software to get started. But then we have our expert team from respective companies to help out if you want a more comprehensive implementation or looking at a more comprehensive engagement. So with that said, I want to thank both Jaakko and Mikael for joining us and sharing your insights. And thanks again to everyone who dialed in and listened. We will, as said, send out a recording with some further information. And we are also planning some more NLP related webinars. So please keep an eye out in your inbox and on our websites, and there should be invites being sent out in the near future. So thanks again, gentlemen, for presenting, and thanks for listening. And we hope you'll have a great rest of your day.
Thank you.